Let's solve this relation using implicit differentiation. So you can see now there's probably going to be the quotient rule involved, right? We have something over something. So let's just get started. So with implicit differentiation, what we want to do is we want to take the derivative, so ddx of both sides, so ddx of y, or I'm just taking derivative of that side, is equal to, and then ddx of x over x minus y. Okay. So now ddx of y, so you can think about this as, well, the derivative of y is 1. Okay, easy enough. But then what we have to do is we have to multiply by the derivative of the inside, which would just be y prime. Okay, which makes sense, derivative of y. Okay, so yeah. All right, so now moving on to the next side. So now what we're going to have to do is use the quotient rule. So I'm going to call the top part of my function here f and the bottom part g. And the quotient rule, just for reference here, f over g prime is g f prime minus f g prime all over g squared. Okay. Now we just need to be careful whenever we run into a y, really, because then we have to use the chain rule on that, and we'll end up with like another y prime out of it. So, all right, so our g. So with our g is x minus y, right? That's what our g was there. F prime. Okay, well, f prime is pretty easy because f is just x, so that's just going to be 1, right? The derivative of x is just 1. Minus, and then f, which is just x, and then g prime. Okay. So I think just to be careful here, let's actually just take the derivative of that for a second. So if g is x minus y, then g prime would be, okay, well, the derivative of x is just 1. Okay, easy enough. Now the derivative of y, well, the derivative of y you can think of as like negative 1. Okay, so negative 1 if you like. But then we have to multiply that by y prime, right? That's like the derivative of the inside. So g prime is really 1 minus y prime. All right, so then if I keep going with my quotient rule here, then that would be 1 minus y prime. Okay, and then this is all over, and then g squared. So x minus y squared. All right, so then we've taken the derivative, but now you'll see that I've actually introduced two y primes, right? Like we want to solve for y prime, but now we have multiple y primes going on. So let's kind of just simplify the brackets up in the numerator here for a second. So what we have left is y prime is equal to, so all of this would just become x minus y, and then I will distribute this negative x in. So now we've got negative x plus y, or plus x times y prime, all over x minus y squared. Okay, so now something that works out kind of nicely here. We've got x and negative x or minus x here, so they cancel. So now we have y prime is equal to negative y plus x y prime all over x minus y squared. All right, so now this isn't good enough, right? Because we need y prime on its own somewhere. We need some way at some point here. I need to collect those two guys together. I need to get them combined into one. So what we're going to do next is we're going to take this denominator here, and I'm going to move it on up to the left side of the equation. So I'm going to multiply both sides by x minus y squared. So now we have y prime times x minus y squared is equal to negative y plus x y prime. All right, so this is looking a little better because I no longer have anything in the denominator. So the next thing I'm going to do is I'm going to take this this term and I'm going to move it over to the other side. And it'll make sense in a minute. So let's just write this again now. We've got y prime times x minus y squared minus x y prime is equal to negative y. All right, so the whole reason I did that, I just needed these two guys to be on the same side of the equation because, watch this. So now I look at this term and I've got y prime, and this term I've got y prime. We're going to factor out a y prime. So look at that. I ended up combining those y primes into one. Now I only have one y prime going on. So I've got y prime, and then I'm going to write what's left. So now I've got x minus, actually here in brackets, I've got x minus y squared, and then I still have minus x is equal to negative y. All right, so now last step here is just to divide both sides by all of this. Right, the whole thing. I'm going to divide it on this side and then on the other side. So then I just have y prime is equal to negative y over, and then that chunk. So now we have x minus y squared minus x. And there we go. Now we have an expression for y prime. You could expand out this binomial if you wanted to, but really this is a perfectly acceptable way to leave your answer.